So, hello friends, I am Dr. Shalin Marathe. Uh, I am PhD degree holder from NIT Surat, and I am having an experience of more than 10 years. So, I run my own competitive exam classes, particularly for the Gujarat government jobs. Okay. In addition to that, I teach students regarding the concepts of mechanical engineering. Okay, and I have uploaded few videos about that also. So particularly in uh, this video is regarding the mechanical engineering, and in this video we are going to talk about the topic that is casting. Okay, and if you are going to go if you are going for an exam, any competitive exam or any written test or any interview. Okay, you are likely to face interview in any of the jobs regarding mechanical engineering. If you are going for any industrial job like manufacturing industry, production industry, so you need to have good command over the questions of casting and concept of casting. So in this video we will see the basic concepts of casting. Okay, IMP points will be covered considering the exam and the interview. Okay, so let us start now. So first of all, you should know that what is casting. Okay, so let us start with the definition. What is casting process? Okay, so uh, casting is a process in which the molten metal, okay, is poured in the casting cavity, and the shape of the cavity is same as that of final product that we need to produce. Okay, so this is a simple definition, not a bookish definition. I would say simple definition anyone can understand. So let us understand this. So in casting process, first of all, we need to melt the metal. First, we need to melt the metal. Okay, so now the metal we have, that is in liquid form. Okay, so if the metal that is in solid form, we need to heat it up and we need to convert it into liquid form. So now we have metal in molten form, so in liquid form. Now this metal which is in liquid form will be poured in any cavity. Okay, that is called as casting cavity. Okay, so pouring will be done in casting cavity. Okay, now then we will allow this molten metal to solidify. So solidification will take place. Then solidification of metal will take place, and after that we will remove or we will take out the cast part. So these are the few simple steps those are involved, or we can say by understanding these steps you can define the casting process. Okay, so casting is nothing but we need to we need to melt the metal. Once we have the molten metal in our hand, we need to pour it in any cavity. Okay, now the shape of that particular cavity depends upon what product that you want to make. Okay, so depending upon the product that you want to make, you need to have the cavity of that same shape and size. So now you have cavity and you have poured the metal inside that cavity. Okay, now since the metal that is in liquid form, we need to give it some time so it will solidify. So next step, that is the solidification. So the molten metal that will solidify and it will be it will be converted into from liquid to solid state. Okay, and after completion of solidification stage, we have to remove the casted part. Okay, that can be done directly. We can remove the casted part, or we need to break the pattern. That depends upon the complexity of the shape of the cast product that we are producing. If it is a very simple block type, then we can directly remove the part with the help of tools available. Okay, and if it is a very complex part and which we are going to produce, then we need to break the pattern. Okay, so this is the definition of casting process. So let us see now which are the different steps involved in the casting process. Steps involved in casting process. So first and very important step, that is pattern making. First, that is the pattern making. Okay, second, that will be mold and core making. Third, that will be pouring and solidification. Fourth, it will be fettling or pattern breaking to remove the casted part. Okay, and the fifth one is inspection. Inspection for which purpose? That we have produced the product without defect or not. So we need to the product that we have produced uh, must we need to check it for the defects like voids and all that, surface defects, crack and all that. So for that we need inspection. It can be a visual inspection and it can be a inspection with some accessories and other inspection devices. Okay, so these are the 5 steps those are involved in casting process. So first step, that is pattern making. So what is that? So whenever we want to produce any part, okay, so for that we need mold. Okay, to produce any part, using casting process, we need cavity or mold, and to make that cavity or mold we need pattern. Okay, so the shape, size of the pattern will be approximately, I would say, approximately same as that of final product that we need to make. Okay, so pattern is nothing but it is the replica of the product that we need to produce using the casting process. So first of all, we must have a pattern. By using that pattern, we will be able to uh, make the mold and core and all that thing. So that is the second step. You can see that is the second step. So by using this pattern, okay, we will prepare the mold and core if required. So once we are done with pattern making, mold making, core making, then we need to melt the metal, and once we have the molten metal in our hand, we will pour it and we will allow it to solidify. So the third step, that will be pouring and solidification. Okay, got it. So we have made the pattern, then using that pattern we have made the mold and cores, and after that we have the molten metal. We are pouring that molten metal into that mold cavity and mold all that thing, and we are allowing that molten metal to solidify. Now after solidification we need to remove the part. Okay, so for that the step is fettling. Okay, that particular stage or the process to remove the uh, what we can say the cast product, that is known as fettling. And at the end, once we have the casted product in our hand, we need to inspect it. So the last stage, that is the inspection. So I hope the 5 steps are clear to you. So now we will discuss how to make the pattern, means not in detail, but which things, important things that we need to consider while we make the pattern. Okay, pattern making. Okay, so first of all, what is pattern? So it is a replica of casting to be made or to be produced, that I have already mentioned. So pattern is nothing, it is the replica of casting to be made or to be produced. So what is the size of the pattern? So pattern size, that is equal to the size of the casting plus or minus allowances. Okay, so if you know what is the casting size, suppose this is the block that you want to produce using casting process, so this is your casting size, this is your casting size. Okay, so in this size you need to give some allowances. Okay, and that if you add it, some allowances are negative, some allowances are positive. If you add this thing, if you consider this thing, then you will have your final pattern size. Okay, so now let us see which are the allowances, and this is the most important part in casting process and also in pattern making. So which are the allowances? So allowances in pattern making. So first allowance is shrinkage allowance. Why we need shrinkage allowance? So as I already told you, when we pour the molten metal in the cavity, it will solidify. So it will go through the shrinkage. It will shrink. So if the metal shrink, the size of the casting that will be reduced. Okay, the volume of the molten metal will reduce, and then it will get it solid shape. Okay, so the shrinkage allowance, why we are providing shrinkage allowance? Because we are pouring the molten metal that is in liquid form. Once the liquid that will be converted into solid due to the solidification, okay, so the size, okay, the size of the casting will reduce. So in order to compensate that, we need to give the shrinkage allowances. Okay, so since the size of the casting is reducing, the shrinkages allowances are positive. Okay, so let me give you one example. So this size that I want to make. Okay, so I have created the mold like this. Okay, so now if I will pour the molten metal, okay, like this. So this is the molten metal. Okay, and after solidification it will be like this. It will take this shape. So this will be the gap. This amount of metal material that I want, that is not available. Okay, so the size of the casting is less than I want. So this thing need to be compensated, and that is compensated by giving shrinkage allowance, and that's why the shrinkage allowances are positive. Okay, all the allowances are given on pattern. Okay, so if the pattern size is increased, if the pattern size is increased, this particular box will be bigger. Okay, this particular box will be bigger like this, just for example. So even if the material shrinks, we will have near about shape. Okay, okay, we will have, obviously, it will what we can say, the size of the casting will be more than what we want, but that can be removed with the help of machining. But if the size of the casting that we want, that is less than what is the desired, then we cannot do anything. Okay, so that's why the shrinkages allowances are given, all the allowances are given on the pattern. But why the shrinkage allowance is positive, that I am explaining to you. Because when the material shrinks, okay, the size of the casting will reduce, that's why. Now let us understand the second allowance, and that is machining allowance. Machining allowance, now already I have told you that if you give shrinkage allowance, your casting will be bigger. Okay, like this much it will be bigger. So to remove the excessive material, to remove the excess material from the casted part, we need to give the machining allowance. Okay, So this machining allowance is again given on the pattern, and that is also positive. Okay, because when we produce the product, okay, any part using casting, you will find that the surface finish is not good. Okay, so all that things we need to, if you want to achieve good surface finish, you need to machine it. Okay, so once we have the raw product after casting, to achieve the necessary looks, or to achieve the necessary, what you can say, the surface finish, you need to machine it. And that's why we need to provide extra material on the casted piece. So to have this bigger casted piece, we need to make the pattern bigger. So to make the pattern bigger, we need to give some positive allowances, and these are called as machining allowances. Okay, so that we can remove the excess material and we can achieve the net shape and the surface finish that we want. Okay, then the third allowance, that is draft allowance. Now why we need draft allowance, that you need to understand. So suppose this is the cavity. Okay, and this is the metal that you have poured, and this has solidified. Now this is solid. Now when you will remove this solid casted piece from this cavity, suppose you are removing it, so it will damage this wall. It will damage this, what we can say, wall of cavity. Okay, it can damage the cavity, so you need to make the pattern again and again. Also, some secondary operation will be required if the surface finish of this casted piece, or the wall of the cavity is not as per the uh, desired, what you can say, the configuration. Okay, so that's why we, for easy removal of this casted piece, we are providing some taper on the wall. The tapers are not that much big, but to understand this, we are just, I am drawing this figure like this. Okay, so if the piece solid metal is like this, so it is easy to remove. Okay, once the piece is lifted, okay, there will be no less damage, you can say, there will be less damage on the wall of the cavity or mold, and also on the solid casted piece. Okay, so these allowances are given to easy removal of, draft allowances are given for the easy removal of the casted piece, and these are again positive. So these draft allowances are given on pattern and are positive, which are given to for easy removal of the casted piece. Fourth one are shake allowance. Once the piece is ready, solidification is done, we are shaking this entire setup. Okay, so that the separation over here takes place quite easily, and we can remove this solid casted piece. Okay, so we are, what we can say, we are shaking the mold box for easy removal of this casted piece. And that's why, and when we shake this, okay, when we shake this, uh, the size of the casting piece that will increase, and because of that these allowances are negative. Okay, these are the only allowances which are negative, all other allowances are positive. Because when you shake the pattern, okay, the cavity will be bigger. Okay, when you shake the pattern, and because of the shaking, the cavity will become bigger. Let us understand that. Okay, so again take the same shape. Okay, so now here I have put the pattern. Now I am shaking this, all this, the entire setup. So what, this is sand. Okay, this is molding sand. Okay, so because of that, what will happen, because of shaking, is the size of the cavity will increase, since we are shaking the mold box or the setup. So since the cavity size increases, the size of the casted piece will increase. Okay, okay, so in order to compensate this, we need to make the pattern smaller. Okay, so if we want to produce this size of casted piece, okay, and I am making same size of pattern. Okay, this is the, let me draw again, this is the product, and this is the same size of pattern. Okay, now while preparing the sand and the cavity, I have put this pattern over here and I am shaking it. So you will get your product bigger. Okay, much bigger, because of shaking. So in order to compensate this thing, okay, why waste material, this much material which will be removed using the machining process, so more energy is wasted. So in order to reduce the secondary operation, if we by what we can say, if as a corrective measure, as a what we can say proactive, if we take this kind of practice, proactive mind, what we can say thinking, then we will make this pattern more smaller. Okay, not of this size but small size. So even if we shake it, it will reach up to the size that we want of the casted piece, and because of that, the shake allowances are negative. So these are the only allowances which are negative, all the other allowances are positive. And the last allowance, that is distortion allowances. These distortion allowances are given for if the casting piece is like this U shape, so due to distortion it will be, due to solidification and distortion, the shape of the casted piece will be like this. Okay, so to compensate this kind of geometrical distortion, these distortion allowances are given, and these are not positive, not negative, but the of the pattern shape of the pattern will be adjusted somewhat, we can say. Okay, so these are the 5 important allowances which are provided on pattern. Shrinkage allowances to compensate the solidification, these are positive allowances. Machining allowances to achieve the better surface finish, okay, we need to machine it, these are also the positive allowances. Draft allowances to, for easy removal of the produced part, we need to give the draft allowances, these are in terms of degree, you can say angles. Okay, so these are also the positive allowances, means the pattern will become bigger. Shake allowances are the only negative allowances, while after putting the pattern, while we are making the mold and all that things, cavity, when we are generating the cavity, we put the pattern and we shake it. So because of that, the size of the cavity will increase. So to compensate it, we need to decrease the pattern size. So that's why these allowances are negative. And then we have geometrical distortion allowances, and these are not positive negative, just you can change the shape of the pattern accordingly so that after solidification it will take the desired shape. Okay, so I hope these 5 allowances are clear to you. Okay, now again let us see somewhat some features of these allowances. So first is shrinkage allowance. Okay, so obviously it is provided on the pattern, and these are the positive allowances. Okay, now you need to understand over here. Okay, so this allowances take care of only solid solidification. Now what is the meaning of that? Okay, so let me give you a brief idea about that. Okay, so uh, at pouring temperature we have this, what we can say, the molten metal. So we have molten metal at pouring temperature, and that is in liquid form. Okay, we pour it and it will have its own freezing temperature. Okay, that will be again in liquid form. After reaching this freezing temperature, it will reach to solid freezing, again freezing temperature, but for solid state. Okay, so here there is a change in state, liquid state to solid state. Here there is no change in state. Okay, so you can say like this: solidification happens into liquid to liquid and solid to solid. Okay, so once the metal reaches freezing temperature of solid, then it reaches to room temperature, and again here it will be in solid form. So again there is no change of state. Okay, so this liquid to liquid shrinkage, and this is solid to solid shrinkage. So this liquid to liquid shrinkage, that is taken care by riser. We will see in detail what is riser. Okay, so here I am just giving you just a concept of riser, that when there is a shrinkage from liquid state to liquid state, that will be taken care by the riser, that is the component of what we can say, the pattern, this cavity preparation, riser, sprue, runner, all that we will see in detail. So riser will take care of liquid to liquid shrinkage, but this solid to solid shrinkage, that will be taken care by shrinkage allowances, that we are providing shrinkage allowances, which are positive and given on pattern. Okay, so this is the most important point that you need to understand and remember that. So first of all, the liquid will be in molten state, and from that it will reach to the freezing temperature. So there is no change of state. Okay, so there will be solidification from liquid to liquid state. Okay, and that particular thing is taken care by, compensated by riser. But after reaching to freezing temperature in liquid form, it will reach to freezing temperature to solid form, and from this solid it will be reaching up to the room temperature. So again there will be solidification and shrinkage will take place from solid to solid, and for that we need to give this shrinkage allowances. So if someone asks you that why we need shrinkage allowances, so simply you can say for the solidification. So but which type of solidification, is it liquid to liquid or solid to solid? So you can say the shrinkage allowances are given to take care of shrinkage from solid state to solid state, from freezing temperature to room temperature. Okay, so I hope uh, that is clear to you. Then second is machining allowances. So I have already told you in detail that these are again given on the pattern. These allowances are given on the pattern, and these allowances are again positive. Okay, so some extra material that is provided on the pattern, on the pattern okay, for good surface, good, or you can whatever, increased surface finish of final product. And how you will achieve that? By machining. So that's why these are called as machining allowances. Okay, so this machining allowance that is provided on the pattern, so uh, that will increase the size of the pattern. Okay, suppose this is the size of the pattern without, okay, after machining allowances it will be somewhat bigger. Okay, so because of that your casting size will be bigger, casted piece. So to if you machine this surface, okay, if you machine by uh, this surface, vertical wall, horizontal wall, you will have your final piece, final product, that will be of net size that you want, desired size. Okay, so if you do not provide this machining allowances, after casting you will have your final product size, but the surface finish of the product will not be good. That is not acceptable in some cases. So in order to remove this excess material, not having good surface finish material, we need to machine it, and that's why we are providing machining allowances that is on the pattern, and those are positive. Okay, then I have explained you the draft allowances. So these draft allowances are for easy removal of pattern material, easy removal of pattern material. Okay, so let us understand this. So suppose this is pattern. Okay, so you have prepared this cavity. Okay, so your mold is ready. Now you are removing this pattern so that you can uh, pour the molten metal. So when you remove this pattern, because of friction, because of contact with this surface, contact of this, what we can say, sand and the pattern material, your surface will be like this. It will be like this, and this will result in, if you pour the molten metal over here, your final cast piece will be look like this, which is not acceptable. The surface finish that is not desirable. Okay, so how we can avoid this? How we can avoid this kind of problem? That if while removing the pattern, if this contact is eliminated anyhow, then we can have better, not this much rough but improved surface finish. So for that, what we are doing, we are making pattern like somewhat like this will be our pattern. So what we are providing some angle over here. Okay, we are providing some angle over here. This is known as draft allowances for easy removal of pattern material. Okay, so for internal surfaces, for internal surface of this pattern, this allowances is about 5 degree to 8 degree, and for external surfaces this is around 1 degree to 3 degree. Okay, so you need to also remember this value, that roughly the external draft allowances are from 1 degree to 3 degree. If it is the internal surface, then you need to give it around 5 to 8 degree. So this is for easy removal of pattern material. Now shake allowances I have already explained you in detail. That is the fourth one. Shake allowances, only negative allowance. This is the only negative allowance given on pattern. Only negative allowance given on pattern. Okay, so let us understand this again. So this is the pattern. Okay, okay, so now uh, if we want to remove this pattern, and also uh, we will shake this entire setup, what it will do, it will increase it will increase the size of the cavity. It will increase, okay, this much it will increase by some amount. By some amount it will increase the size of the cavity. Okay, this is your pattern, this is your mold wall. Okay, and here we have sand, this is the sand. Okay, so after all the things that has been done in the pattern making, we need to remove the pattern. And for easy removal, already I have told you that we have gone through that. We are providing draft allowances, and also we will shake the entire setup, entire mold box. So what that will do, that will increase the size cavity by small amount, that you can see in this figure or you can understand. So that will increase the, what this will do, that will increase the cast size. Okay, I want this much amount of final piece, but due to shaking, the final size of the product, that is increasing by this much amount. So in order to reduce this thing, we are providing shake allowances on the pattern, and these are the only negative allowances, okay, given on pattern. So that you need to remember. If you are making the pattern using wax or mercury or polystyrene, then you need not to give any shake allowances. So that is the advantage of this pattern material. We will discuss the pattern material uh, in upcoming times, that for some pattern material there is no need to give the shake allowances. Okay. Similarly, the draft allowances are not required for the pattern if it is made from mercury, polystyrene or wax. Okay. Then the last allowances are distortion allowances. Last allowances are, I think, the fifth one. Yes, fifth one, the distortion allowances. Okay, these are the only allowances which are geometrical allowances. Means geometrical means shape allowances, you can say, and these are again given on pattern. Obviously, all the allowances are given on pattern. Okay, so now let us understand this. Okay, so if you want to have final piece like this, okay, suppose this is the final piece that you want after the solidification that has been done. So if you will make uh, your cavity like this, so but during solidification, uneven heat dissipation will take place. Uneven heat dissipation will take place, and that will lead to the distortion of metal. Distortion of metal. So because of that, what will happen? Your product will be like this on after removal. It will be like this. Okay, so now suppose after one or two trial you are coming to know that these legs are bending out, okay, by some degree, 2 degree, 3 degree, 5 degree, that depends upon the condition to condition. But let us say you are constantly you are noticing that of 5 degree there is some distortion. So what you can do, you can make this pattern or your core or your mold like this. Okay, so when you remove this casted piece, again distortion will take place. Okay, that we cannot avoid, but due to distortion, this distortion will help us to achieve our desired shape. So if the in this case the distortion will happen, what will happen, it will move outward by 5 degree, so it will take shape like this, and that is the shape that we want. Okay, like this, that is the U shape that we wanted. So this is just a one case and one example to understand the concept of distortion allowance, that that is only for casting of shapes like U and V shape. If you are producing such shapes using the casting process, so different shrinkage at different location will take place, that we know. Okay, if there is a if the there is large amount of quantity that is gathering in any area, so the solidification will take time. If the quantity of molten metal in some areas are less, it will solidify quite faster in comparison to other areas. So due to this uneven heat dissipation or uneven solidification, there will be distortion. So how to handle such cases? So in such cases, practically, if I have to talk, so after one or two casting, you are noticing that this is my desired shape, but the final shape that I am uh, getting, that is being distorted by 5 degree, 2 degree, 3 degree. Okay, so measure that particular distortion and allow that distortion, uh, compensate that distortion in pattern. Okay, so that pattern will produce such a cavity that will be not exact, that will be not same as the exact shape of casting, but after distortion the casting will take final shape that we want. Okay, so in this lecture, up to this only, so we have gone through very important points, allowances. In next session or next video we will move forward and we will see types of pattern, then pattern material, common pattern materials we will see, then we will see which are the elements of a molding sand, which are the additives that we can add to increase the property of molding sand. Okay, so these are the points that we will discuss in next video. Okay, hopefully. So I hope I have explained the casting process. So I hope that you will understand this process, and particularly allowances you will understand, and further we will see in the next video. So thanks for watching. Keep supporting, keep following StudiHQ on Instagram, YouTube, and Facebook. If you have any doubt or query, you can uh, simply WhatsApp me or DM me on Insta, or comment on this video on YouTube or Facebook. You can comment or you can message me. Okay, so thanks for watching and keep following StudiHQ. Thanks.